So I want to return back to our 2005, 2006 NBA data, right? So again, we have the average height for the players in the NBA for that season was 79 inches. The standard deviation was 3.89 inches. And of course, there's 430 total players rostered that we gathered that data from. Now what this video is going to quickly show is we can work in an inverse way within our tables. And so in our in previous videos, we've said, okay, we're going to calculate some standard normal value, right? Z equals x minus the mean divided by the standard deviation, right? Our standardizing formula. But we can then use that Z value, right? And we can find the area underneath the curve on our chart, our Z distribution chart, right? So given a Z value, we can find the area underneath the normal curve that corresponds to it. But what we're going to do in this, we're going to look at a really quick example to say that we can also go the other direction. If we have an area underneath the normal curve, we can move back and find a Z value, and then along the way, ultimately, we can get to some value of Z. So if we look at our NBA basketball players' height, again, it mentioned that it's approximately normally distributed. Obviously mean shifted off the general population, but it's approximately normal. Again, with our mean here at 79. If I asked the question and said, what is the lower boundary on the top quartile, if you will? Or what is the boundary on the 75th percentile, right? So here's our top quartile. Also our 75th percentile would include the 0.25 and the 0.50 or the half that's below the mean. But if I basically said, what is the height that separates in the NBA players, the top, we'll say 25% from the rest of the players in terms of height. We can find that value. The first thing we can do then is say, all right, well, what do we know? Well, we can use this 0.25, this area underneath the normal curve, and it'll tell us then that the corresponding value, right, if we work backwards in our table, if we have 0.25 somewhere around there, it's going to get us to a corresponding Z value right around 0.67. So the Z value that lines up to this value of X is 0.67. We're going to put that in our formula over here. 0.67 equals, we don't know what X is, that's what we're looking for, minus our 79 divided by 3.89. Okay, as we simplify this formula, I'm going to multiply each side of the equation times 3.89. Right, times 3.89. Our 3.89 times 0.67 gets us to right around 2.61. So 2.61 equals X minus 79. Let's get rid of that 79, isolate X. 81.61 equals X. The height of NBA basketball players that separates the top quarter, if you were, top quartile, all right, or the 25th or the 75th percentile on height ends up being right around 82 inches. Again, this video is just a way to show that we can, the big idea is that we can move both directions from that table. Obviously from a Z value over to a normal area underneath a normal curve, but we can also go the other direction with that table as well.